Welcome to Summarize Science, where we break down complex research into simple terms. We've all been amazed by AI video generators like Sora, which can create stunning, realistic videos from a simple text prompt. But a huge question remains. Are these AIs actually intelligent, or are they just incredibly sophisticated copycats? To find out, researchers created V-ReasonBench, which is essentially a standardized IQ test for these video models. It's designed to see if they can understand logic, physics, and patterns, not just create pretty pictures. The benchmark is divided into 4 main categories to test different kinds of thinking. First is structured problem solving, which includes tasks like doing math, solving Sudoku puzzles, or even figuring out the best move in tic-tac-toe. Next is spatial cognition, testing if the AI can understand how shapes fit together or complete a symmetrical pattern. Then there's pattern-based inference, which is like those classic, what comes next in the sequence, puzzles. Finally, and perhaps most interestingly, is physical dynamics. This tests whether the AI has an intuitive grasp of real-world physics, like if a block will slide down a ramp due to gravity. The researchers tested 6 of the world's top video models, including the famous Sora, 2 from OpenAI. The results, shown here in this summary table, were fascinating and revealed that no single AI is the best at everything. For example, Sora, 2 was a genius at structured, logical problems, scoring a 72, far ahead of its competitors. However, when it came to understanding physics, Sora 2's score was only a modest 26.67. Other models, like Hailuo, 02 and Vidu, Q2, were the exact opposite, excelling at physics while struggling more with logic puzzles. This shows that these AIs have very distinct strengths and weaknesses, likely based on the specific data they were trained on. One of the most interesting findings was that some models seem to prioritize aesthetics over accuracy. When given a simple tic-tac-toe board, some models would creatively change it into a detailed chessboard or a cartoon scene, failing the test. It's as if the AI got bored and decided to make art instead of solving the puzzle. Another bizarre behavior the researchers found was temporal hallucination. In one test, an AI correctly guided a mouse through a maze to the cheese in the final frame. But the video process showed the mouse literally walking through solid walls to get there. So while it got the right answer, its thought process was completely nonsensical and broke the laws of physics. So let's recap the key takeaways from this research. Researchers have developed a powerful new tool to measure the actual reasoning abilities of video-generating AI. Their tests on top models like Sora, 2 show that while these AIs are incredibly capable, their intelligence is not yet like a human's. They have spiky, uneven skills and can sometimes cheat or get distracted by the desire to be creative. This work is incredibly important for the future of AI development. By understanding how these models think and where they fail, developers can build more reliable, robust, and truly intelligent systems. These tests will help push AI beyond just mimicking reality towards genuinely understanding it.